purpose of the load curve. It gives us a very concrete idea that how we are generating and meeting the load accordingly to the demand of consumers. Right? So a typical or representative load curve looks on your screen. A typical load curve may be demarcated by 4 cardinal points. You can observe it. We have got some troughs, some crest for the 24-hour cycle, and you will find that, as I told you on that day also, morning peak, day lean, evening peak, night lean, so on. So these are the important points, or more importantly, cardinal points in a daily load curve. These 4 cardinals exist in load curve. However, shapes, width, magnitude may vary state to state, means consumer to consumer, and depends upon the customer types. That is whether they are domestic, agricultural, commercial, and industrial. So mind you, load curve of domestic consumers, agriculture or industrial consumers will be different. And the overall load curve of all these consumers can be combined together and plotted as well. States where weather dependent loads are more predominant may play important role in making the shape of the load curve and varies during the summer and winter season. We have all discussed it on that day. So this is how a load curve is plotted, and it gives us a very fair, a very good idea of variation of the demand of consumers. So you must keep it in your mind whenever we talk about the variation or load periodicity. Diversity of load was not discussed. So diversity in load, the various types of load define the shape of our demand curve, not only the magnitude of demand, but also its seasonality, hourly variation, peak variation, and occurrence depend on the nature of major load of a region. There are many factors which go into the load, and diversity is going to be one of the most important factors. You will learn many things for diversity in coming slides. Now, daily variation, you understand the load curve shape, peaks and leans are determined by the major type of load in that area. For residential consumers, the demand peaks more in the evening when residents switch on different loads. For commercial loads, these are higher during 8 to 6 p.m. when the offices and commercial complexes are operating in full flow. Seasonal variations, I think we have discussed it. The economic factor, since electricity has become a daily life necessity, it has also turned to be a commodity. I told you that why it is termed nowadays as a commodity. And since it is a commodity, we can exchange it. So energy exchanges have been set up. And like all other commodities, for example, most common is the Sensex. We can trade this commodity as per the changing prices. Now, the generation varies according to the demand. If the demand is low, we are not going to generate at the same pace when the demand was at its peak. So generation has to be varied according to the requirement of demand for simple and obvious reasons. Because if we do not keep pace with the demand, the situations will get very difficult for us. It will not be easy to save the grid in that case. So for obvious reason, the demand has to be taken into consideration for the generation purpose. Now, during the lean period of the load curve, say from midnight to early morning, the demand is at lowest. You can say it is at the leanest time. There is less and less demand. Now, the base load of the load curve, the base portion of the load curve is that which is the minimum demand that is being catered by the generating units. And for stability purpose and other things, we need to supply the base portion of the load curve continuously. As and when the demand increases, we need to switch on more and more generating units. So now you can have a feel that if the generation is generating part of the load curve and demand is at its lowest, the cost of the generation will definitely have low values. And in contrary, if the demand is at its peak and we have switched on many generators, still we are at the base demand, we are going to import from different regional grids or from somewhere else. Obviously, the cost of generation is going to increase. The utilities are going to incur more and more in terms of economic factors. So this creates a kind of difference in the energy rates. So on less demand, the electricity can be sold for less as compared to when the demand is at peak and the cost of electricity is higher. Now, this is the kind of pricing that goes as far as commodity of electricity is concerned. Thus, economy of the state has also an impact on the uses of electricity. The increase in purchasing capacity of the population fuels the spurt in demand. There is no denying the fact. Moreover, rapid industrialization and modernization has also added to the demand growth. If the per capita electricity consumption is compared with the per capita income of the population, there is a definite positive correlation, as more per capita income implies larger per capita electricity consumption. Now, this is not difficult to understand, because when the economic condition of a household, of a particular section of the society or a particular region or a state improves, then they have got enough resources or enough money to spend on some luxury items, something related to their lifestyle activities. So they try to spend more on other things related than simply food, grain, housing, or essential items. Now, this goes into the increment of energy consumption. This is the meaning of this point. Electricity demand curve. So previously we had a lot of discussion on load curve. Now, electricity demand curve. The study of demand diversity and its evolution has been a major area of focus for every developed or developing country. Continuously matching energy generation and demand is at the heart of electric systems because of their little storage capacity. The challenge is to balance demand with generating resources adequately, exploiting its flexibility and diversity. Now, this is the purpose of all the power utilities, that they will try their best to balance this demand and generation. Regional diversity in demand. India is a big country, you all know. Western, southern, northeastern, something like that. And we are on the process of having a single grid. Large geographical area of India is demarcated electrically into 5 regions from power system operation point of view, and each region has its unique characteristic. It is not that demand variation or demand diversity for northern and southern or western grids are similar. It's not like that, because some states are industrially advanced and some are where the agriculture activities are predominant. Even in different mega cities, demand variation is quite different. For example, if we take the case of Delhi, the northern grid, it does not have much industrial load. Rather, it has got commercial and domestic load. So the variation of demand in Delhi as compared to Mumbai or Chennai or Hyderabad is going to be somewhat different. So we cannot say that regional diversity of all is going to be almost similar. They are going to be different. The type and nature of load, difference in climatic, geographical conditions, and cultural practices also affects the demand curve of a region, making it very different from that of the other. Diversity in maximum demand. Electrical diversity factor, you must have read it in your previous semester also, is the ratio of the sum of the individual maximum demands of the various electrical components of a grid to the maximum demand of the grid. The value of the diversity factor of an electrical grid usually exceeds 1, simply because not all the individual maximum demands are going to be switched on at the same time. So the value of diversity factor will always be and should be more than unity. Diversity occurs in an operating grid when all loads connected to the source are not operating simultaneously or are operating at less than maximum loading. This is the meaning of the diversity. The sum of individual power requirement maximums of a system is always larger than the total system maximum. That is the meaning of maximum demand. Diversity continued the same thing. Continuing, the diversity factor indicates this time interdependence of the different components of the system on the total power requirement. So as a ratio, sum of individual maximum demand, the simultaneous maximum demand. Now, greater the diversity factor, lesser is the cost of generation of power. How can we say that? If the diversity factor is greater, cost of generation is somewhat lower. If anything, if everything, all electrical equipment is running at full load at the same time, the diversity factor is equal to 1. But that is not the nature of the demand curve. That will be the easiest kind of thing for a service utility to have such situation, because in that case we need not worry about the stability problems, the grid or the frequency going down, something like that, because there is no variation on the load. Demand side is very efficiently matching the supply side. Everything is in constant synchronism. Nothing is going to have, there is no shock on the our system. But this cannot happen. Consumers are there to give you shocks. The diversity factor is an important indicator of variation of maximum load across different parts of the country. Interconnection of grid helps in harnessing this diversity. Now, earlier, in very earlier times, when we got independence, and the process of industrialization and modernization began, began in our country, engineers and the power planners realized that we should have different type of regional grids. Regional grids means all the generation, all the load, everything should be connected in synchronism so that we are able to match the demand and the generation of electricity in a better way. So this was the basic idea behind the establishment of regional grids. And once the regional grids started functioning well, we thought that why should not we have a single grid, a national grid, in order to have the same kind of advantages that we thought of states. Because if some of the grids are having more generation and less demand, they can simply export their power to the grids which are facing greater demands. This kind of situation is going to give some respite to our power system engineers. The overall power availability situation is going to improve for the country. People are going to utilize the resources in a better way. And it is good for the combined power system of the country also. So interconnection of grids help in harnessing this diversity. Diversity in minimum load is also important. The simultaneous minimum all India demand would be much higher than the sum of individual minimum demand of different states on account of diversity. The diversity factor for minimum loads can also be computed in similar manner, which would always be less than 1. The same way that we computed for the diversity factor for maximum load, we can calculate the diversity factor for the minimum load also. Analysis of demand pattern. Demand variation pattern, be it through a day, week, month, season, or year, depends largely on the type of major portion of the load driving the demand. Some assumptions on the type of major load of a particular state can be done to its load factor and difference between peak and lean demand as a percentage of peak and its seasonal variation. This kind of data predicts that what is going to be the variation in the demand in different seasons, in different months, at different point, and we can plan accordingly. The important observations with regard to states are as follows. Now, there are certain observations that have been collected from different regions of our country. All the states approximately follow a common pattern, wherein the difference between its maximum and minimum demand met is less during the summer, while the same increases during the winters. Now, this may be accorded to more demand of space cooling loads as compared to space heating load during the peak hours. It is not difficult to assimilate. Demand of cooling load is more as compared to the demand of heating load during the peak hours, because cooling conditions are more required than the heating in our country, because it is a tropical and subtropical climate operating for most of the time of year. So major exception to this is the state of J&K, the Union Territory of J&K, where this difference falls during the winter season, November to February, instead of rising as that of other states, primarily due to space heating requirements. They don't require much of the air conditioning units like other states. Similarly, other hilly areas of Himachal or Uttarakhand also, so they need more of the load fulfillment during the winters rather than the summer. With major domestic and commercial loads such as Delhi, Chandigarh, and agricultural loads such as Punjab, Haryana show large variation in the difference of their peak and lean demand, as such loads are more susceptible to seasonal variations. Suppose there is a good monsoon season. Now the agricultural load demand will definitely go down, and we can divert our power to the industries rather than channeling it to the agricultural or rural sector. And if the monsoon situation is not good, definitely things are going to be very difficult, and we need to supply more and more power in order to the requirement of our farmers. States with major industrial loads such as Maharashtra comparatively show lesser variations, as they are somewhat more inelastic to seasonal changes. On the last discussion also, that the demand in the industry is going to be on a constant pattern. It is not going to change, unlike the seasonal activities, because it has got almost no reasonable impact on the industrial activity. Now take the example of Kerala. It has the lowest percentage variation in the difference of its maximum and minimum demand met throughout the year, despite being one of the least industrialized state. Kerala is not a very industrialized state, and still the variation in the maximum and minimum demand is minimum, simply because its geographical location is very unique, and there is nothing like summer, or you can say the winter conditions, which are very severe in northern states. So this is the reason that there is minimum variation. So such is the diversity of our country, and because of this diversity, our power system planners are getting sleepless nights. Now the correlationship. The correlation is one of the most common and most useful stats. It is a single number that describes the degree of relationship between two variables. The correlation value is always between -1 to +1. If the correlation is negative, it indicates negative relationship. If it's positive, the relationship is positive. If its value is 0, then obviously there is no relationship between the two variables. Now, how does it relate to our power system? A state having a strong negative correlation between two states indicates that when the demand of one state is increasing, at that time the demand of other state is decreasing. So it is a kind of negative correlation. This gives a clue to bilateral arrangements between the parties. This will lead to optimal utilization of resources and economic efficiency. For example, Uttar Pradesh and Uttarakhand, at the onset of winter or autumn, the demand in UP somewhat reduces because the harvesting season has not arrived. Still, they have got some cooling period in the agricultural load. The domestic as well as commercial activities do not require the seasonal peak demands as it occurred in the summer. At the same time, in Uttarakhand, the situations are still not severe because winter is somewhat away. So when the winter approaches, the demand further goes down in the planes, because the power guzzlers like air conditioning units, big cooling units are not required at all. Only heating is required. And if the temperature is not abnormally low, people don't need these kind of heating space arrangements. So this is an example of correlation between two neighboring states. Now, what has been the international experience on demand? The study of demand diversity and its evolution has been a major area of focus for every developed or developing country. Continuously matching energy generation and demand is at the heart of electric systems because of their little storage capacity. The challenge is to balance demand with generating resources adequately, exploiting its flexibility and diversity. The difficulty of it has been further aggravated with increasing renewable penetration. Now, here comes something which needs a better focus in order to stabilize our transmission systems. That when we are going to have renewable generation and its further penetration in the grid, we need to be somewhat cautious, because the stability issue, the generation of active and reactive powers, which are not in the same way in renewable technologies or in renewable generation. So finally, the key is to understand the daily load demand curve, its seasonality and trend, which help in forecasting the future demand and hence proper planning. Globally, increasing demand for cooling heating loads. The climate of most of the world's largest and fastest growing cities have tropical to subtropical climates like China, India, and these Southeast Asian countries, Thailand, Indonesia, Malaysia, Vietnam also. With these cities increasingly becoming urban, industrial, and affluent, the energy demand, particularly for thermal comfort, is increasing drastically. This demand, widely known as heating, ventilation, and air conditioning (HVAC) load, is the major driver of the difference between peak and base load demand, which might have fundamental economic implications in terms of requirement for power generation capacity as well as transmission and distribution infrastructure. So there is a huge bandwidth, you can say, between the peak and the base load of the chronological load curve, and there is a huge gap between the peak and base load demand. Moreover, it is found that globally we have higher electrical demand for space cooling than space heating, which can be somewhat attributed to tropical and subtropical climate, as we all have seen. Now, what are the mathematical modeling that is done, how we calculate the forecasting? The basic technique used for forecasting here is extrapolation. We see that increment from last year has occurred in summer. So this year also we are going to have the same rate of change for summer as the previous year, depending upon the starting values of the generation before the onset of summer or winter. In extrapolation technique, trend curves are fitted to basic historical data, which is adjusted to reflect the growth trend. Using the trend curve, the forecast is obtained by evaluating the trend curve function at the desired future point. Though it is very simple procedure, it produces reasonable results in some instances. Such a technique is to be classified as deterministic extrapolation, as no attempt is made to account for random errors in the data for an analytical module. So whatever we have seen for the past data, we are going to incorporate for our future projections also. So if there is sudden spurt in demand or there is some decrease, then we cannot manage all these things. Recently, you must have observed that the international crude prices of petroleum at the start of corona fall below the, you can say, the decrease was so large that the companies had nothing they could do in order to sustain the supply and demand equation, because they simply lost the ability or have no storage capacity in order to retain the supply, so that they can retain it and they can supply it when the prices are somewhat better. So if any country had still some storage space, they were going to buy the crude at the lowest prices in history. Now, this was the situation in the month of April, or at the end of April, and even in May. So sometimes such situations also happen when we are unable to predict the future, and it is almost impossible. We cannot predict the situation, that is the pandemic situation or something like that. One never knows what is going to happen in next year or next months. So, what is the way forward? The analysis done provides useful information about the trend and seasonality pattern of demand met of each region and state. Similar exercises done at the intra-state level would provide good insights. This information can be helpful in generation, transmission, and distribution planning by the central and state level power system planning agencies by identifying areas, sectors with maximum growth. It can also provide useful insight of the behavioral pattern of the population residing in that region. This exercise throws light over the peak load growth for the coming year, suggesting adequate capacity addition. With the widening gap between the peak and base demand, one of the plausible solutions comes out to be load staggering, which can be very promising in dealing with the future demand growth in India. Load staggering means we have got some way so that we can continue with the same kind of generation, and we need not stress our systems or generating utilities, because simply we don't have capacity to produce more or generate more. So what we do, we stagger the load. Like we can shift the clock also in some cases. The time zone difference may be created, say from northeast to the western. We can have a creation of half an hour or 1 hour time difference, so that the peak occurring in the western zone of our country, it is not synchronizing with the same at the eastern or northeastern places. So the availability of power can be very much optimized with the requirement of load. Now you can have certain data regarding the overall power sector situation in our country. The data has been compiled till 31st October 2016. The pattern is somewhat same. It has not changed very drastically, though now we are having more and more stress on renewable rather than the conventional generation. So you can have a look at this all India installed capacity. We have different sectors like central, state, private. Now you see, only 25% power is generated in the central sector. States have got 33, and the private industries or the private sector has got 42% of its share in total installed capacity. In the same way, we have got different thermal, nuclear, hydro, renewable. So still almost 70% from fossil fuel generation, though it is slowly and slowly coming down. By this time, I think 65 or 66% may be the share of thermal. Nuclear is almost static, though it was predicted to have some 8 to 10% share, but due to certain reasons, the escalation in nuclear generation has not been on the rise. Hydro has got very huge potential in India, especially the small hydro generation. But still, we have not been able to exploit this kind of potential. Renewable is rising at a very good rate. So the overall total capacity is almost 307 gigawatt. Summary of capacity addition targets for 12 plan. It was somewhat a bit old data. So they wanted to add some 15,000 megawatt for thermal in central pool, then state, then private sectors. So still you can think that the capacity addition in thermal was way ahead with nuclear, hydro, and they have not given the data related to the renewable. The plant load factor, you can observe, it is 58.13. It has quite much improved. and the per capita power consumption is almost 1100 units. Now, increase in demand of power due to following factors: rural electrification, GDP growth, 24/7 power to all. Increase in demand has to be there. If the demand is not increasing, then we can say that we are also not progressing. Changing landscape of Indian power sector and recent developments. Increasing share of private sector in capacity addition. Now, this is very much required because the government on its own cannot have enough capacity addition simply because of lack of funds. At the same time, the losses, which are going to be sometimes more than 20%, 30%, in some areas more than 30%. So the government sector has been by and large very inefficient in managing our power sector situation. So the share of private sector is increasing and increasing. There are fuel related issues, inadequate availability of domestic coal and domestic natural gas, difficulty in obtaining clearances for coal mines, inadequate fuel supply agreements for coal, deallocation of coal mines, all sort of things that can undermine the existing power projects and cause hardship to all sections of people. Time, cost overrun, and funding related issues, all the things, land acquisition, poor financial health, all these are crippling things for the power sector. Long term and medium term demand projections. It is estimated to sustain 7.4% growth till 2047 as per the reports of Niti Aayog. Installed capacity needs to increase from current level of 300 gigawatt to 562 gigawatt by 2030. So in turn, in almost 10 years, we need to add almost 190 gigawatt of power. It is almost 372, I think. In the month of August, the total installed capacity is 372 and 562 required by 2030. So in a decade, we need to add almost 190 or 200 gigawatt of power. By 2047, 1112 gigawatt must be available. This is the long-term power projection. Medium-term projection, next 5 years, power sector requires 294 billion US dollar investment, out of which 118 billion US dollar investment is required in renewables. And you must be aware that the renewable capacity of 175 gigawatt has to be there till 2022. It has been set by our present government that by 22, in next 2 years, we must have 175 gigawatt of renewable capacity. There is no doubt that huge investments are required. However, the investments flowing into the power sector will depend on the reform measures, structural changes, improving the overall attractiveness of the sector. So when the private sector is coming and is sharing the major burden of power requirement, unless we provide them greater incentives, no private sector player will be attracted in power sector. So the government policies must facilitate the private private investments because government has no capacity, no resources to meet these projections. So private sector participation is the only hope. Various fund initiatives of government of India, how do we wish to realize this much of capacity? Indian Renewable Energy Fund, 1 to 1.5 billion dollar US dollar, and what we need, 118 billion dollar US dollar investment for the renewable, and the government has provided only 1 to 1.5 billion dollar. Now there is an organization, Power Finance Corporation, that has been entrusted to invest 100 million US dollar. So still we are not enough funds. Renewable Energy Certificate Fund providing long tenure, low cost fund to stressed hydro projects, fund for supporting small hydro stressed asset equity fund. So these are the funds that the government and the government sector undertakings they get from different securities and bonds they raise from time to time. Then there is Masala bond plan to raise 100 million US dollars. I don't know how much it has been able to realize. Initiatives of Government of India. Now the nodal agencies have been given the task aims to deliver low cost power through competitive tariff during international tariff based bidding, economies of scale benefits as each project is 4,000 megawatt each, higher efficiency due to supercritical technology. So this was about thermal power or fossil based. IPDS outlay of 9.6 billion and this much of strengthening of power distribution sector in urban areas. Now you know that the state of distribution sector plays a very important role in order to increase the T&D losses or the theft. All kinds of inefficiencies occur on account of the poor distribution management. So a lot of money has been invested by government as per the World Bank initiative. Initiatives of Government of India, as you might have heard that Deen Dayal Upadhyay Gram Jyoti Yojana, the rural electrification program, has been operating since quite some time. The target is to provide 24-hour electricity to all households and at least 8 hours of quality power supply. Now the distribution or discoms, the private or the kind of companies that have been created out of this state electricity boards, they have been restructured and they are constantly asked to reduce their losses to 15% and further in coming years. And at least they should be economically viable to carry out their operations and earn some kind of profit. Earlier, they used to incur losses, huge losses. So in renewables, the target is 175 gigawatt, out of which 100 gigawatt of solar and 60 gigawatt of wind, and remaining from other small 24 by 7 power for all. I don't know, by this time it has not been realized, but still we have been able to narrow the gap between the demand and supply. The situation is getting somewhat better as compared to the previous decade. A comprehensive program encompasses overall development of power sector, including reforms at all India level. That comprises of generation, transmission, and distribution capacities, operational efficiency. All these things we shall discuss in the restructuring of power sector and reforms in power industry in our next topic. So these are certain initiatives. We are making some progresses in the key areas, but still the situation in rural areas is not very encouraging. So that is all about the forecasting and load requirement for our Indian power sector industry, how we wish to do it, how we wish to achieve it, the policies laid out by the government of India, and how much we have been able to meet out the targets is all here to see for all of you. So it has been somewhat long discussion about the future energy demand, how we wish to analyze, how we wish to realize our target, and what are the different steps that go into making us from energy deficient to energy surplus country. India has got a huge power potential, especially in the areas of hydroelectric, small hydro plants. They are the future of hydro energy apart from the solar. So we shall go through these areas separately and we shall devote quite a lot time for separate discussions in all these renewables. So I think we should stop our discussion here